Hey everyone, this video we're going to be looking at intermolecular forces in a little bit more detail. Just want to recap what intermolecular forces are. So first of all, if you have a molecular compound that forms a molecule, so basically two nonmetals, you're going to have covalent bonds holding the atoms together. And these are super strong. They hold the atoms and they determine the chemical properties of a substance. They're called intramolecular bonds because they're inside a molecule. Now, molecules can have attractive forces between them. They're primarily electrostatic attractive forces. And what happens is the molecules are attracted based on positive and negative sections. Now, the strength of these attractions is really dependent on the amount of charge. The more charge, the stronger the attraction is between molecules. So because the attraction is between molecules, we call it intermolecular force. And these determine things like melting point and other physical properties. So basically, the stronger these forces are, the harder it is to move these molecules around, even to separate them and things like that. So we're going to be looking at the first one. The first type of force, or intermolecular force, is called dipole-dipole. You can see here how we've got these positive and negative ends of these molecules being attracted to each other. Why is that? Well, the example I was using is hydrogen bromide. Hydrogen bromide has a difference electronegativity of 0.8. And clearly, bromine has a much stronger affinity for electrons. So this end of the molecule is going to become a little bit negative, so partially negative, and the other end is going to be partially positive. So we've got these two ends. They're both charged ends. They're like poles. So we call these dipoles. And what happens is the dipoles attract each other. So opposite dipoles do. So here I'm going to have the positive end of this molecule attracted to the negative end of this one. And it basically forms a little network pattern. Now remember, this is not a true bond. These are just attractive forces, kind of like a magnet, right? These are sticking together in that way. And what happens is the bigger the difference in electronegativity, the higher the attraction that there is. So let's look over here. Hydrogen bromide had a difference electronegativity of 0.8. How about hydrogen chloride? Well, it's 1.2, or hydrogen fluoride, 1.8. So as you're going up here, there's more and more difference in the charge. So you're going to have a much more positive end, much more negative end, because of more uneven sharing of those electrons. And as a result, the attractive forces between molecules is much, much larger as well. So basically, the larger the difference in electronegativity, the greater the charge difference, the more attraction, the stronger the intermolecular force at the end of the day. Now, this also ties into melting point. So the highest melting point would be hydrogen fluoride because it has the highest attraction between molecules, the highest intermolecular force. So again, this is an example of dipole-dipole forces. And again, you have to have a polar molecule in order to have a dipole-dipole intermolecular force. Okay, now, what would happen if I took hydrogen and combined it with one of these three, the most electronegative elements on the periodic table? Well, what happens then is you end up with something called a hydrogen bond. Now, hydrogen bond happens when hydrogen is associated with nitrogen, oxygen, or fluorine. So it could form ammonia, water, or hydrogen fluoride. And because there's such a large difference in electronegativity, we have a super strong dipole-dipole force. And this means that it's almost in its own category. And we call these intermolecular forces hydrogen bonds. Even though they're not bonds, they're just really super strong dipole-dipole IMFs, or intermolecular forces. So this is by far the strongest intermolecular force. And this explains why water is liquid at room temperature. There's such a strong attraction between these molecules. Same thing with ammonia. Hydrogen fluoride's not a liquid, but it still has a lot of attraction between the different molecules there. Now, you have to know hydrogen bonds in water are responsible for its unique properties. So what happens is, we already saw this, water has an extremely high surface tension. Surface tension is the attraction between molecules on the surface. And because of all the hydrogen bonds, such a high difference in electronegativity, the water molecules really stick together. And this allows the bubble to form on the penny, It also allows certain insects, for example, to even walk on water. That's really cool. Now, uh, the high strength of the hydrogen bond also means it takes a lot of energy to heat up something. So if I wanted to heat up water, I have to basically make it vibrate. That's what really heating up means. And the stronger these intermolecular forces, the harder it is to make this water molecule vibrate. So it takes more and more energy to make it move. And that's exactly what heat capacity is. So it's a very high attraction. It results from the very high attraction between water molecules. It makes them difficult for them to vibrate. So you should jot these down on the note in your workbook page. I forgot to mention that earlier. You might want to go back and do the surface tension note as well. Now, we also have a very high boiling point. Well, boiling point is, it basically means that the water molecules are going from a liquid state to a solid state. What does that mean? They're actually, all the water molecules in a liquid are basically sliding past each other. There's a lot of attraction. If they have enough energy, they can actually pop off and leave. They have enough energy to overcome the attraction between the other molecules of water. So it's a lot of attraction, but if you have enough energy, boop, you're out and you're free. So the high attraction between water molecules makes it difficult for them to leave the liquid and become a vapor. So that results in the high boiling point. And there's also something about the density. So liquid water is really cool because it's very densely packed, but when it forms a crystal, the water molecules form a hexagonal crystalline pattern and they actually separate. So there's more space between the water molecules when they're a solid than what happens in a liquid. This is opposite of anything else. And this explains why ice can float on water. So again, make sure you jot this down as well. And all of this is explained by these very, very, very strong intermolecular forces, these hydrogen bond intermolecular forces. Very strong, holding these molecules together. So that's it for dipole. In the next video, we'll be looking at other forces that don't involve proper charges on the molecules.